Hello, everybody, and welcome to Dot to Dot. Today, we're going to talk about the number 522, and I'm going to basically give you some evidence or proof that they were using pre-1668 French units of measure when they developed Nolan's cross. And I'm also going to show you a little bit of sacred geometry associated with Nolan's cross and how it basically locates precisely the south anchor. And that is critical. So we will first give you a little bit of review about 522. 522 was recently given by Philip Stevenson in his document. And of course, these are the symbols that we're familiar with that were in La Formula. And when translated, it comes out to 522. Another interesting point is, how did he know this is a distance if this is all he had? The only place that I know that it's referenced 522 as a distance is in La Formula. And this is La Formula right here. And this was fully deciphered by, I believe, a university that was hired by the Oak Island team to decipher it. And with the translations, and I've done this before, this is on a translator, but when you translate it from French to English, and this is the substitution of those symbols, it comes out to 522 feet. So that's interesting. So we're going to talk about 522 first of all, and how it relates to Nolan's cross. Well, Nolan's cross, and this is Nolan's cross right here, is from the top stone to the headstone. It's right here. And if you take this distance from here, from the headstone to the end stone, and flip it over, you hit the north anchor, and we get what we call the extension triangle. And that's what we're going to talk about, is these triangles here. Now, this triangle is, let me bring up the Nolan's cross thing again. This triangle, which is right here, its height is 429 feet. Okay, Nolan's cross from one side to the center is 360 feet. So the total length of Nolan's cross is 720 on the crossbar. So we know this is 720 feet. Now I've got this out. Here's Nolan's cross here, properties, and the measurement is 720 feet. So we have 720 feet laid out here. Now, this measurement here that I've measured, one of the sides is 560 feet. So this is 560 feet. Each one of these segments is 560 feet. So let me show you something. 560 feet. Well, let's go back to here. Okay, here we have 522, and we put that into a calculator. And the third element we put in is 80 degrees. 80 degrees, here's the 560 measurement, 720, and the angle C here is 80 degrees. So we'll put that 80 degrees in, and the 522 feet substituted for 560. We get a number of 671.07. So say 671 feet. This should be equal to 720. This is pre-1668 French units of measure. 1720 is our, or 720 is our measurement. So let's bring the calculator up, and we'll put in 720. divided by 671 equals, so we get a ratio of 1.073 to 1. So 671 times 0.073 should equal 560. Yes, 560. So we can do that. So 522 equals 560.1. Well, there's a lot of numbers here, so we got to take in consideration all these numbers. They do add up after a while. So 560. So let's take our unit of measures in millimeters, which is 304.8, okay, and multiply it by 1.073 equals 327. Now, Wikipedia says pre-1668 measurement units for a foot are 326.569. I believe this is what they're using right here, 327 millimeters. So, pre-1668 units are incorporated into Nolan's cross. This measurement right here is 522 feet. So this is part of Nolan's cross right down here. It is part of the geometry, and it is mentioned in 2 documents so far. It's mentioned in this one, 522 feet, and it's also mentioned in La Formula, 522 feet. And that means that Nolan's cross is connected geometrically to these 2 documents. Now, another thing that I want to show you guys is, I've been saying this is 430 feet and this is 290 feet. And when we talk about these measurements here that we're looking at, how did they get these measurements? I mean, it seems to me that they would be out measuring them to get down to 429 and 293. But we know that we just calculated this one, and we calculated it by, this is 399. So this is the measurements, pre-1668 measurements. So let's do this. 390. So we're going to go 1.073 times 399.875. Let's just do that. Times 399. Oops. Let's see. 399.875 equals 129 feet. Or 429 feet. I'm sorry, I keep saying that. 429 feet. That is the measurement of Nolan's cross right here. Okay. How does that relate to Nolan's cross as far as the distance of the 1347 measurement, which is found on the Rochefoucauld map? So if we multiply that by 1.073 equals, we get 1,445 feet. Now I've been using 1440, but I'm thinking 1445, it's within my tolerance. But let's do this. Let's divide this by 2. And then let's subtract the 429. we get 293. But how did they get that? I just got that by using 1347. I got that by using 1347. How did they get 293? Interesting. Just a thought. All right. Enough of the 522. Now I'm going to show you guys some sacred geometry. So let's see. The first thing we want to do, zoom out a little bit, and we take, let's see, this is what I was just talking about. These are the scales, and these are set to 1445 now. This is this is the scale. This is the distance that was found on the Rochefoucauld map. 1347, that is given in pre-1668 units. If we multiply 1347 by 327 millimeters and then divide it by our millimeters, we get 1445. We just showed that. So let's take, this is a circle that is coming from the center of the end stone. So the end stone is the center. And if you notice, it goes through the oak entrance, and it also goes through what we call the hole. These are points that are on the Rochefoucauld map. Then we'll take the north anchor and we'll put a circle around it. And of course, we get a perfect Vesica Pisces with each of its centers or each of its circles going through that. That's standard. This is fixed. We cannot change this because it is part of what is on the ground. So that's going to be something that we can't change. And so we have a line, and this line goes through, just to prove, it goes through the center of the cross. That's just pure mathematics. That's going to work out every time, just like that. So the thing that I wanted to show you is before I was using, let's see, I was using the scale line that was coming from triangle 2. And that is, let's see, where is that? Right here. So I was using this one where the center is triangle 2, and it was going through the north anchor and the south anchor. But then I was realizing that somebody had mentioned in the comments about the location of the south anchor isn't really verified within this theory of this 45, the 1445 theory. So this scale. So what I did is I took the south anchor and I made it the center of a circle. And so I got this. Now that is a little bit more obscure in that how do you know where the south anchor is to get the center? How do you know where it is? Well, it may be a complex geometry, but watch this. If you find that this Vesica Pisces, if you find the center of the south anchor you would take the Vesica Pisces and cross them through the headstone out, and you would get the 4 points of the radius of a circle. Do you see what I'm showing you here? All these circles have Vesica Pisces. There's one here, there's one here, and then there's the main one that we have here. If you connect them all, and they are connected, they are right on. They are right on. All of them are dead center. And they all cross, not perfectly, but I mean, pretty close. How close? With like 1.29 feet, in a couple of feet, they cross at the headstone. They cross at the center. Now, if you take this south anchor, I mean, there's no way that that can't be precisely done. $445 feet. 444.9. That is right on the circle. And if you move that around, look at the Vesica Pisces are so like interrelated that if you move that around, it's not going to, let's say you put it right there. There's no way that that's going to intersect the center of that. No way. So just a little, I guess you could call that sacred geometry. When you look it up on the internet, there's an article here that, that it was related to Christians, and that there's ratios here that are all associated with the Vesica Pisces. I'll put this article in the comment section, and you can relate, you can watch it or read it. Pretty interesting. It's very sort of mathematical, but anyway, I wanted to show you guys those things. It's pretty cool. Definitely Nolan's cross has a lot going on. I think the fact that the north anchor and the end stone are related in such a way that this relationship with the south anchor being so precise, it only gives you a mathematical way of finding the south anchor. You don't have to measure it, so to speak. You just have to know where the north anchor is, and you can calculate where the south anchor is by using sacred geometry. I don't know that much about it, and even if I did, I think it would bore you guys to tears to do a bunch of math calculations. But there it is in Google Earth, and it's really hard to get these things to match up. This is very, very precise in its location. And we got a lot of different things. We have the north, the triangle 2. Oh, that was the other thing, is when you put in the center of the south anchor, it actually locates triangle 2. So I think this is the way it was meant to be. It was meant to be done this way. And triangle 2 is now the next point. You get Nolan's cross figured out by using the 522 measurement here and knowing to flip that over the mid-pointer stone to the extension triangle, and then extending it out to the north anchor with this measurement here. And it's all there in scale and in measurement distances that you can recreate this. And once you have that, if you do the math, you get the intersection point of these Vesica Pisces, and you can find the center of this circle, which is the south anchor. How you would do that mathematically, I don't know. These guys must have been geniuses. But this is it. This is the 45-5, or this is the 1445 theory now. And it is, it didn't make much of a difference that this was changed from 1440 to 1445. It makes more sense mathematically with Nolan's cross and its configuration. But the fact is this is what I have here cannot be relied on as location, because I don't really know exactly where all these points are. And I think you need to know where they are. You have to be on the island. So if they came up to me and told me to calculate it and put an X on the map of where I think anything is, I couldn't do it. Unless I knew the GPS coordinates of Nolan's Cross, I couldn't do it. But if I did know the coordinates, GPS exact location of all the stones on Nolan's Cross, you could figure this out mathematically. And on paper, you could figure it out. And it is pretty, it's not really all that hard, except for maybe this. But, you know, one of these days, and even Aaron Helton didn't have any coordinates to go. So, you know, she was sort of shot down, and I don't know. Aaron Helton sort of got the short end, I think. I hope they bring her back, and hopefully maybe she'll contact me, and, you know, we can get some of this information and try it out. But anyway, that's all I have for you today. I hope you liked it, and thanks for watching. Bye.